Okay, so in this identity, we want to show that 1 plus the cosecant of theta, all divided by cotangent of theta, is equal to the tangent of theta plus the secant of theta. And when you're verifying an identity, you want to start with the more complicated side and use that as your given information, and then show that it equals the less complicated side. So this fraction looks pretty complicated. I'll go ahead and start with that. So 1 plus cosecant of theta divided by cotangent of theta will be my given information. So now in order to try to end up with two separate trig functions here, I need to split this one fraction into two fractions, and my numerator is a binomial. So I can go ahead and break that apart into 1 over the cotangent of theta plus the cosecant of theta divided by the cotangent of theta. And that is separating into two fractions. Right? If I had, since these have a common denominator, if I wanted to go backwards, right, if I had added these fractions together, when you add fractions, you add the numerators, 1 plus cosecant of theta over the common denominator. So I can see that those are equivalent by working backwards. So now I'm going to take a look at this 1 over cotangent of theta, and that's a reciprocal identity, so I can change that into tangent of theta. And that is using a reciprocal identity. And then on this side, I have tangent of theta plus, and if we look at the trig identity hexagon here real quickly to recall our quotient identities, I believe this is a quotient identity. So tangent goes on the leftmost vertex, then we have sine and cosine, then the reciprocals are secant, cosecant, cotangent, and we always put a 1 in the center of the hexagon. So if you recall our quotient identities, they follow consecutive vertices, either clockwise or counterclockwise. So for example, tangent is the quotient of sine over cosine, or you could write tangent as the quotient of secant over cosecant, because those are consecutive vertices. Now if I look on my trig identity hexagon here for cosecant, that is here, and cotangent is right beside it. See how those are consecutive vertices. So this ratio of cosecant over cotangent, that's coming from this corner, which is secant. That's moving counterclockwise around our hexagon. So secant is the quotient of cosecant and cotangent. And so I can change this into secant of theta using a quotient identity from that trig hexagon. And that is what I set out to do, right? I set out to show that 1 plus cosecant of theta divided by cotangent of theta is equal to tangent of theta plus secant of theta, and I've done it, and so this identity has been verified.